Hi.
Hello guys, can you hear me well?
Yes.
Yes.
All right, let's start right away. I'm going to take the attendance first. Abdel Halim.
Miss, are we going to correct the homework today?
Yes. Abdel Halim is not here. Okay. Adham.
Here.
Ahmed Ahmed. He's joining. Ahmed Hatem. Ali Walid.
Here.
Okay. Amr Hatem is not here. Hamza.
Yes.
I need you all to mute your mics, please.
Okay.
Julie.
Here.
Judy.
Here.
Lina.
Here.
Mira.
Yes.
Nancy.
Yes, Miss, I'm here.
Ruqayya.
I'm here.
Do you have a question?
Yeah, of the homework.
Salim.
I'm here.
Yusuf Sajid. Okay, Ahmed Ahmed. Abdel Halim. Abdel Halim. Okay. Okay, guys, let's correct the homework together. I want you to open page 47, please. Open page 47, please.
Missy said 47.
Yes, I said 47. That was the homework. Did you do the homework?
Yes, I think so.
You think so? Okay. So in page 47, question number 1 says, when you hold your hands around a mug of hot chocolate, your body gets warmed. Why? You're talking about the flowing of heat. The flow of heat. Yes, Mira?
Because the heat of the hot chocolate mug will travel to your hands.
Okay, so because the thermal energy in the hot chocolate will flow from the hot chocolate to the walls of the mug into your hands, right?
Yes.
Okay, so the heat from the hot chocolate will flow from it to the walls of the mug to your hands. Is it hard?
No.
Okay. The next question says, a winter scarf is a good example of thermal insulator. Who would like to answer this one? A winter scarf is a good example of thermal insulator. You just need to write the definition of thermal insulator. Who said me?
Me.
Who is this? Who said me?
Adam.
Okay, Adham, answer it.
Because it doesn't conduct heat well.
Yes, because it doesn't allow the flow of heat through it, okay? Because it doesn't allow the flow of heat through it. Okay. Question number 3.
Miss?
Yes? What?
Yes.
Who's asking? Someone is asking a question?
Me.
Okay, Mira, yes.
Me, Ruqayya, and Ahmed Ahmed.
Ruqayya and Ahmed Ahmed. Okay, yes, Ruqayya, what's your question?
I can't understand the question number 3 and 4.
We're going to do it right now.
Okay.
And Ahmed Ahmed, what is your
Miss
question?
Nisma?
Ahmed Ahmed, do you have a question?
Miss, no.
Okay. Yes, Mira. Do you want to say something? Mira, do you want to say something?
Yes, I was saying that I wrote yes, it stops the heat from your body escaping into the cold air.
You just need to write the definition of thermal insulator. You don't have to write all of this. What is a thermal insulator? It is a material that does not allow the flow of heat through them. This is it.
Okay.
Okay, the next question. A hot drink is used in a thermoflask. What is the thermoflask? It is a kind of mug that a lot of people use, and I myself use it, that you can travel with it. So you put the hot drink and you close the lid, and you can go to work or go to the school with it, and it keeps the drinks hot for a long time inside it. So do you know what is the thermoflask?
Yes.
Okay, so the question is why? Why does it do this? Yes, Ali. Why do you think does it do this? Since it keeps the drinks hot. So this means that the thermoflask is made of what?
It's made out of plastic, so it can keep the heat insulated.
Exactly. So it doesn't necessarily have to be made of plastic, but any thermal what?
A thermal insulator will
Exactly.
keep it.
Thank you so much. So the thermoflask is made of a thermal insulator, and this is why it doesn't allow the heat from the hot drink to flow through them, so it keeps it inside the drink. Ruqayya, do you now understand?
Yes.
Okay, so thermoflasks are made of thermal insulators, so it doesn't allow the heat to flow through them, and it keeps the heat in the drink. Is it clear for everyone, guys, how it works?
Yes.
All right.
Yes.
Oh, all right. Can I now?
Miss, I wrote. Miss,
Yes, dear, I can hear you. You wrote?
I
wrote what,
wrote yes because if you don't want. I wrote yes because if you don't want your hand to be burned, so yes.
No, no, this is not why the thermal flask keep the drinks hot. Okay, I need you to write what I just wrote.
Miss Nisma,
Yes?
Okay.
I wrote yes because it is an insulating storage vessel.
Give me 1 second, guys.
Miss?
Yes, guys, I'm sorry, I'm back. Yes, Mira, again, please, what did you just say?
I said I wrote yes because it is an insulating storage vessel.
Where did you get these answers from, dear?
I wrote them.
No, you got it from somewhere. Did you Google it?
No.
Okay, did someone help you with it?
Yes.
Okay, I need you to answer.
I did all of this on my own.
I want you to answer it according to your knowledge, Mira, okay? Because this way you're not anchoring the information well in your head. Do you understand me, dear? So I want you to
Yes.
think about it. If there is something that you're confused about or that you don't know, do like Ruqayya. Wait for me until we do it together and then you can understand it well. Okay? Don't use big words because this will not help you. Right? Okay, did you
Yes.
finish, all of you guys, did you finish copying number 3?
Yes.
Eh, did you finish copying number 3? All right. I'm going to erase it now and we're going to do number 4 together. Number 4, cooking pots are made from metals while the handles are made of wood. I think I asked this question several times during our sessions. Cooking pots are made from metals while the handles are made of wood. Julie, can you answer this one?
Okay.
All right. Cooking pots are made of metals, while the handles are made of wood. Why?
Because
Let's start with why cooking pots are made of metals.
so that the heat can't
Can
get out of the weights.
no.
Because
What
the heat can't.
travel to what? What do you put inside the cooking pots? What do you put inside the cooking pots? What do we use the cooking pots for?
For eating food.
Yeah, exactly. So you want to cook food. So you put raw food inside the cooking pot. So it's very important that it's made of metal so that the heat can reach the food and the food will be cooked, right? Because metals are good or bad conductors of electricity, of heat. Are they insulators or conductors, metals?
Conductors.
Exactly. So metals are conductors of heat so that they can make the heat or transfer the heat to the food and the food will be cooked. This is the first part of the question. The second part is why are the handles made of wood? The handles of the cooking pot, why do we make it of wood or plastic or stuff like this?
Miss, can I answer it?
No, she will answer it. Julie, tell me, the wood is a heat conductor or a heat insulator?
A heat insulator.
So it's very important that the handles are made of heat insulators so that we can do what? Can you touch the cooking pot from the metal part?
No.
So you touch or you handle
so that we can't be burned.
Exactly. Thank you so much. Thank you, Julie. So the answer, guys, is that it will be it will consist of 2 parts. Okay. The first part is that cooking pots or metals are conductors of heat. So it will allow the heat to flow to the raw food and cook it. While the handles are made of wood, which is an or a heat insulator, so that our hands
Miss,
won't.
you wrote hello.
Okay, I will do it. I will fix it now. Won't get burned. While the handles are made of wood, which is a heat insulator, so that our hands won't get burned. Metals are conductors and so it will allow. Okay. All right. Ruqayya, do you understand?
A little.
A little?
Yeah.
What's the problem, dear? What is the problem, honey?
Miss, can you hear me?
Now I can hear you, but did you say something?
No. I
Okay.
was trying to tell you
Yeah, tell
that
me.
I'm a little bit confused of number 3.
Number 3,
Yeah.
I asked you and you told me that you're fine with it.
Maybe you didn't hear that I closed my mic when I told you.
Okay, number 4, do you understand number 4 now?
Yeah.
Okay, number 3, dear, a hot drink is used in a thermoflask. A thermoflask is a kind or a type of cup or mug that is made of a heat insulator. So now if you put any hot drink inside it, the heat from the hot drink will not pass through the walls of the thermoflask because it's made of an insulator. So it will not let the heat pass through it and get to the outer air. It will keep the drink hot because it will not allow the heat to pass from the hot drink to the air because it's an insulator. But if it's a conductor, if it's made of a conductor of heat, the heat will pass through it really easy, and this way the heat will flow from the hot drink to the air surrounding it, and it will make the drink colder now because it's losing the heat. It's losing the heat. The heat is getting out of the hot drink. But if it's surrounded by an insulating material, the heat will not get lost. It will stay inside the hot drink. And this is why it will stay hot for a long time.
Okay.
Do you understand? It's very important for me that you understand. I don't want you to say okay and you're still confused.
No, now I understand it.
Okay, dear. And what about number 4? Do you understand number 4?
Yes.
Okay, let's go to number 5. Number 5 says you are having a hot dinner. Please mute your mics. You are having a hot dinner on a cold day. You are having a hot dinner on a cold day. What happens to it if you don't eat it straight away? Ahmed Ahmed, what will happen to the hot dinner in a cold day if you did not eat it right away? We said that the heat flows from what to what? From the cold to the hot, or from the hot to the cold?
From the hot to the cold.
Yes. So the material that has more thermal energy will pass it to the material that has less thermal energy. So this is why the heat flows from the hot substance to the cold substance. Now you have a hot meal surrounded by cold air. So the heat will flow from where to where?
The heat will flow from the heat will flow
You have
to the cold, and the cold.
dear honey, you have a hot meal surrounded by cold air. Tell me, how will the heat flow? From where to where? From the air to the meal, or from the meal to the air?
From the meal, from the air to the meal.
How? Is the air hotter than the meal?
The hot dinner to the
Cold air. Yes, exactly. So the heat will flow from the hot dinner to the cold air around it. And this is why after a while, what will happen to the meal? Will it stay hot?
It will be cool.
Exactly. And this is the answer for the question. You have a hot dinner surrounded by cold air. After a while, if you did not eat it right away, after a while, the heat energy from the hot dinner will get lost in the surrounding cold air. And this is why after a while, the dinner will turn cold. Do everyone understand, guys? I need you to please wake up with me. Do you understand?
Yes.
Yes.
All right.
Yes.
So the hot dinner, the heat energy in the hot dinner will flow to the cold air surrounding it. And this is why after a while, the dinner will become cold. Okay, so what happens if you don't eat it straight away? The answer will be the heat, yes, the heat from the hot dinner will flow to the cold air, and the meal or the dinner will become cold. Is it clear for everyone?
Yes.
Okay. The last question, question 6. You are in this page. You are having a cold drink on a hot day. Now, this is the other way around, guys. Now we're talking about the opposite situation. You have a cold drink on a hot day. What will happen to it if you leave it for a long time? Hamza, can you answer this one? Are you there, Hamza?
Yes, miss.
Okay. Now, again, let me just state something. Let me ask you a question. The flow of heat is from the hot to the cold or from the cold to the hot?
From the hot to the cold.
Very good. So in this case, what will happen to the cold drink?
It will stay cold.
It will stay cold?
No, it will become hot.
Yes, because it is surrounded by hot air. So the heat will flow from the hot air to the cold drink.
Cold.
Yes, so after a while, the drink will turn hot.
Hot.
Okay, thank you so much.
Yeah.
Does everyone understand?
Yes.
Okay,
Yeah.
the heat from the hot air will flow to the cold drink, and it will turn hot. The drink, of course, the drink will turn hot. Okay, guys, did you copy? Should I erase and flip the page?
Yes, I still didn't. I didn't finish number 6.
Okay, please finish quickly so that we can turn the page.
Miss Nisma, I made the ball experiment.
Okay, we're getting to it after
Me
a
too.
while. Yeah, all right, excellent. We're getting to it after a while.
Miss, after this page, we still have some questions of worksheet 3. Is that part of the homework?
Yes, I told you that you have page 47 and 48, the whole page.
Okay.
Okay, did you finish copying? Should I erase?
Yes.
Yes.
Okay, let's move to the next page, page 48. In page 48, we have another two questions just like those, and then the experiment. You can tell me what did you do. Okay, number 7. What happens to the liquid in a thermometer when the air around it gets warmer? One word, guys. One word. Only one word. Adham, do you know what is this word? Adham? Okay,
Yes, miss.
yes, dear. So what happens to the liquid in the thermometer when it's surrounded by hot air?
Liquid expands.
It will expand. Thank you so much. The liquid expands. Very good. The liquid expands. Expands means that it's getting bigger. Why is that? Because once the thermal energy of the hot material or hot air gets into the liquid, it starts to make it, the particles starts to move fast, and they really are pushing away from each other, and this is why they expand. Question number 8, what do the marks on a thermometer show? What are they called? Ali.
So the marks on the thermometer show the degree, show the temperature.
Yes, so you answered both of them, but the first one is what do the marks on a thermometer show? It shows how hot or cold the substance is, and
So
what
it means the temperature.
yes,
Means
and
the
what are they called? They are called temperature, because you have two questions. Okay, so the first one is shows how hot or cold a substance or a material or whatever is, and it's called temperature. All right, cold.
Miss, can I answer the experiment one?
I will hear from the people who did it. How many? I want you all to put your hands down, please.
Miss, I can't see the screen.
Lower your hands. What about the rest? Can the rest see the screen?
Yeah.
Yes.
Yes.
Okay, I will stop sharing and I will share again. Okay, I need to erase this so that I can go to the experiment. I want you to lower your hands, please. And then only the people who made the experiment, please raise your hand. The rest of you, lower your hands. Only the people who did the experiment, raise your hand. The rest of you, lower your hands. Okay, so let's take one by one. First, Ali. Hey, Ali, what did you notice? What was your observation?
So my observation was when I put the finger that was in the cold water inside the warm water, it felt like nothing happened. It just felt like I was putting my finger on thin air, but something different happened when I put my finger that was in the hot water, in the warm water. When I put it in there, it felt like I was just putting my finger in in water that's a little cold, in cold water.
Yes,
So
yes.
I didn't feel like there was anything different.
Okay, so you felt like, do you think the warm water felt as if it's warm, or after you put it in the hot water? Did you feel like the warm water is warm, or did you feel it cold because you compared it to the hot water?
I felt it cool. I felt it was cool.
A little bit cool, right?
Yes.
Yes. Okay. Thank you, Ali. Ahmed Ahmed, did you try it?
Yes,
And what did you feel?
I felt like my two hands are the same heat and cool after I put my hands in the warm water. I didn't feel by I didn't feel by anything after I put my two hands in the warm water.
So when you
But
put it in cold water and then you put it in the warm water, how did that feel? Did you
I
feel
felt
like
like
you're putting it in like hotter water?
no, I felt like it's the same.
And even when
Like
you put it in hot water and then warm water, it was the same?
yes, I
Okay.
didn't feel by.
All right. Mira.
Yes, when I put my hands in the cold water, then I put it in the warm water, like both of my fingers, I felt that the water was cold.
When you put it in the hot and then put it in the warm, right?
Yes.
Okay. What about when you put it in the cold water and then put it in the warm water? Did you try it?
Yes, like first I put it in the cold water and both of them at the same time and in the warm water, and I felt it was cold. But when I put my both fingers in the hot water and the other one the cold water, I felt like my other hand feels it's hot and my other hand feels it's cold, normal.
Okay. Adham, did you try it?
No.
Okay. Ruqayya, did you try it?
Yes.
Yes, and how did you feel?
I felt when I put my finger in hot water and then in warm water, I felt that the water all is hot water. And when I put my finger in cold water and then in warm water, I felt it's a little bit hot and a little bit cold.
So when you put it in the hot water and then warm water, you felt like it's hot?
A little.
Okay. But it's colder.
Yeah.
Okay. Well, what you should observe is that when you put your hands, thank you, Ruqayya, this is for all of you now, guys. What you should observe when you put your hands in hot water and then in warm water is still hot, by the way. But since it's colder than hot water, you will feel compared to the hot water like warm water is cold or cool, not cold, but it's cool. Okay. On the other hand, when you put your hands in cold water and specifically the really icy cold water, and then you put it in warm water, you will feel like you put your hands in hot water. So you will always feel the opposite. Warm water will always feel the opposite than the other two types. If you put your hands in hot water, warm water will feel cold. If you put your hands in cold water, warm water will feel hot. Do you understand, guys? Because you're comparing, yes, because you're comparing between warm water and cold water and between warm water and hot water. So if you're comparing, it's warm water will be always the opposite of what you just put your hand in, okay? So the observation in this case will be this way. When I put my hand in hot water and then warm water, the water will feel cool. But when I put my hands in cold water and then warm water, it will feel hot. Okay? Okay, guys, I need you to copy this so that we can go to the next worksheet that we're going to do together. All right, guys, after that, we are going to answer page 53. After finishing this, please finish quickly. We are going to answer page 53.
Miss, do we have homeworks today?
Well, it's according to whether or not we're going to finish today. Okay, if we finished, yeah, the thing, I mean, the worksheets that we are not going to be able to finish it today, we're going to take maybe according to how many also. I will give you a homework.
How many will we do?
Miss, do we
I
open
don't
page
know.
53?
It's according to how much time we're going to take in each of the worksheets. Yes, we're going to do page 53 right now. Did you finish copying? Should I erase?
Yeah.
Should I erase? Did you finish
Yes.
copying? Okay. Now
Miss Nisma,
open.
Miss Nisma, can you
Yes.
show us who sent the homework?
Can I show you what?
The people who sent the homework.
I'm going to do this next time, Mira.
Okay.
Okay. All right.
Okay.
So now page 53. You have a background knowledge first. Some materials such as metal feel cold when you touch them because they take heat away from your hand. When heat is taken away from your hand, from you, you feel cooler. These materials are said to be good thermal conductors because they allow, of course, the heat to pass through them, as they are able to conduct heat. Other materials, such as wood, do not feel cold to touch. They do not take heat away from your hand. These materials are thermal insulators. They are poor conductors of heat. Now, the science activity says 5 spoons made of different materials were placed in a bowl. 5 people each held a spoon while hot water was poured into the bowl. When a spoon became too hot to hold, the holder let go and said, "Now." Here are the results. Now they tried plastic spoon, steel spoon, wooden spoon, porcelain spoon, and aluminum spoon. In the plastic spoon, the one that touched the plastic spoon did not say now. The one who touched the steel spoon after 15 seconds said now. The wooden spoon did not say now. Porcelain spoon did not say now. And aluminum ladle or spoon after 30 seconds. Now, guys, I need to end this session and I'm going to start the new one. So I'll see you now, okay?
Miss, the new session already started.